Julia, what have we been exploring when we think about one person infecting two other people?
Actually, what we're already starting to see here is one of the most important ideas in disease modelling. If we have one person, how many people do they go on to infect on average? This is the key idea. This is something we call the reproduction ratio, but that's such a mouthful that modellers usually just call it R. R is really important as an idea of how quickly an epidemic is going to take off, that early phase in an outbreak. What you've already seen is an example of R equals 2. So you've got one person, they infect two others, and you've seen how quickly that can accelerate. You've also looked at R equals 1, where each person just infects one others, and you've seen that doesn't really accelerate at all. You might like to think about R equals 3, quite how explosive that is going to be. So how does this connect with real diseases? Well, when there's an outbreak of something new, one of the first things that we want to know about is the value of R for that disease, that situation. That's the sort of thing you might be hearing on the news in early days of a new outbreak. As well as new outbreaks, we can think about R for past diseases. I can give you some examples. So smallpox, you will have heard of. It's one of the diseases that's been eradicated mainly by vaccination, and it was absolutely devastating. But before vaccine control, we were looking at R equals 3. You might have heard of polio. It's now very rare because of vaccine control. And again, before vaccination, the typical R for polio was about 5. Another one you'll have definitely heard of is measles. And the value of R can vary a little bit according to context. But if we think about UK in the first half of the 20th century, before vaccination, we're talking about R equals 18 for measles.